Hi, scholars. So, today in computer science, we're going to talk about how we program a computer. But in today's lesson, we're going to focus on how we can use variables in programming. Now, later on in today's lesson, we're going to find out that variables are just somewhere where we can store some data. But because of that word, variable, that data that's being stored, well, it can change to suit our needs in the program. Now, previously, we've learned about how to use our microbits to create uh, nightlights. We were able to ask the microbit to look at the amount of light that there is in a room, and then based off of that, we were able to either turn all the lights on our microbit on or off. In today's lesson, though, we're going to create a game. That game is called Tug of War. In actual fact, I'm going to show you what that game looks like. So this is what it's going to look like at the beginning. We're going to have an LED being shone in the middle of our screens, or in the middle of our microbit, sorry. And the game that we're creating, well, it's a two-player game. Tug of War is played by teams, and in this game, it's no different. Player one is going to be on button A, and player two is going to be on button B. And depending on who button bashes the fastest, that LED will get moved either one way or another, depending on how fast that player is at pressing that button. And again, exactly like a real tug of war, if that rope or that LED goes too far beyond this line on one side or another, then that team wins. So, for example, if A were going to win, and I press that again, there you go, it says there that A wins. And in today's lesson, we are going to create this game. So, without further ado, how do we actually start to do that? Well, the first thing we need is an LED, just a single LED to be displayed on our microbits. This is the block of code that we need to actually do that. It's a plotting block of code. It's purple, so we're going to go off and have a look for that now. When you get to your screens, this is what it's going to look like. Hit where you can see the purple area, click on plot, move it into the forever block, and it will show an LED somewhere up there. But really, we want it to be in the middle, so we can change the value of that to be, well, whatever we want. So I want you to change it around and just see where it ends up. I'm going to put it at 2, 1. There you go. And just see what happens. Well, that puts it there. It's not quite in the middle. So really, we need it to be at 2, 2. That is really the middle of our microbit screens. In actual fact, it starts at 0, 0 up there, as you can see. And every time you go across, it goes 1, 0, 2, 0. And if we want to go down there, then it's, well, 2, 1, because we've gone across 2, but down 1. And that one there is 2, 2, because we've gone across 2 and down 2. So now that we've got our LED there, well, it works, but nothing happens when I press the buttons. So what do we need to do next? Well, now that we've got our coordinates already, we've got that LED to shine in the middle of our screens at coordinates x2, y2, we need it to start moving one way or another, depending on which buttons are being pressed the most. So having a look at the input section, we need to add the A button and the B button. And something's going to happen based on those inputs, right? So let's go back to our code. And in our inputs, I'm going to add in on button A pressed. And I'm going to add in another one. But instead of it saying A there, I'm going to get it to say B instead from that drop down menu. So something needs to happen if those two are pressed. But this is where that variable comes in. A variable is a value stored in memory that can change while the program is running. It's like creating a box and storing something inside of it. In our game, our box has an identifier, and we want to call it rope, for example. right? Because we want to know where the rope is at any one time. And inside that box, we want to put the x coordinate of that rope. I think we're all in agreement that the y coordinate doesn't need to change. It doesn't need to go vertically, it needs to move horizontally. So we need to change the x coordinate depending on which buttons are being pressed. So once we have a variable created in memory, whenever the CPU is told to fetch that data, it knows where it needs to go. And it goes to that box called rope and then just picks out the value that's in it. So currently the value that's in it is the number 2. But the value can change depending on the buttons being pressed. For example, if the B button is pressed, then the value needs to increase by 1. So from 2 to 3. So now, when the microbit goes to that location in memory where rope is, and it picks out the x coordinate, it now picks out the number 3. Rope is our identifier, but the data inside of it is our value. So we need to keep track of where rope is. So what we need to do is create a variable called rope and set that to 2 at the start of our games. So let's create a variable called rope. We need to set rope to 2 at the start of our games. And then we want to say, well, if the A button is pressed, we want to change rope by -1. And if the B button is pressed, well, we want to change rope by +1. Know that if we go -1, the LED will move this way, +1, the LED will move the other way. So back to our variables, we want to change rope by -1, remember, for A. And I can just right click and duplicate that and say change rope by +1 if the B button is pressed. Perfect. There we go. So going back to plotting our block, here we go. Will the LED ever really move if we use this block? Well, hold on. Haven't we just said that if the A button is pressed, we can change rope? Well, hold on. Let's try that now. Hold on. Pressing my A, pressing my B. Hold on. That LED is not moving. It's because the only thing that's telling that LED where it needs to be is this block here, where it says plot X2, Y2. That 2 is never changing. So what we need it to do is this. We need to change it. So instead of it saying plot X2, we want it to say plot X rope. What that's going to do is going to say, well, whatever the value of rope is, add that in there. So let's try that out and see if it works. So I take from my variables, I took that value rope and put it in there. So now, whenever I press that A button or B button, and it changes that value of rope, it also changes the location of that LED. But wait, we have got a problem, don't we? We need to make sure that we clear the screen before plotting the LED. Currently, we've just got a line of LEDs. We don't know where the LED is because, well, we can't tell. So if I go back to there, I don't actually know where that is. I've got no idea. So we need a way of clearing the screen before plotting our LED in the first place. So in our forever block, really nice and simply, in the blue section, there is a clear screen. So now it will forever clear the screen, then plot. Clear the screen, then plot. Clear the screen, then plot. So now when we move it, it's been cleared to plot the next one. There we go. Now our LED is moving one way or another. Wait, once I pressed that A button, wasn't the game meant to stop? Or the other way as well? Hold on. Nothing seems right here. While we've got our LED to move, we haven't really got a game yet. So how can we add in a sort of game element to this? How can either person A or person B win this game? Well, we need to use an if statement like we did in the last lesson. But instead of it being light level, or what we're doing is tracking where the rope is. So the yes or no question that we need to ask this time is, well, if my rope is ever less than -2 or ever greater than 2, then A wins, or if B wins. I like that idea. So let's see if we can change this to say forever, if rope is equal to 0, then show string A wins, or if rope is equal to 4, then show string B wins. Let's change that up. Sorry, I'm going back to my code now. So in my forever block, I'm going to move it down there so everything's nice and neat. So I'm going to say, in my logic, if, if, I'm going back in there and click the equal sign. So I'm going to say, if my rope is ever equal to 0, which it is there, then I want to say A wins. And again, I can just right click and duplicate. I'm going to say, well, on the other end, where the x coordinate is 4, then I'm going to say that B wins. So let's do that. Make sure it works. So if I go that way, just one more, there you go, A wins. Or if I stop that and play that again and go that way, B wins. Problem is, though, that we haven't really gone off the screen. So that just means we need to change the coordinate by one more. So 0 is there. Well, the other side of 0 is -1. The other side of 4, well, just 5. So let's see if that works. So if I move it off the screen, now A wins. And if I move it off the screen in the other direction, now B wins. That works a lot better. But in actual fact, if you were to download and play your games, well, it's just a bit quick. So how can we make our games even better? Well, we want it to last longer than 5 seconds, so what can we do here? Instead of using integers, which are whole numbers, we can change the x coordinate. We can use floating point numbers, numbers with a decimal point. We'll call them just floats. So instead of saying we can change the rope by -1 every time we press it, let's change it so it now says -0.5. Now the game's going to take twice as long. In fact, you can change that number to whatever you want. I can change it to, minus 0.5 there and minus 0.5 here. Oh, sorry, plus 0.5 here. And now when we play our game, like I said, it is just going to take just that little bit longer. Look, more clicks to get that to move. But if it's still going too quick, well, we can change it to 0.1 or 0.2. Doesn't matter what it is, as long as they're both the same, then it's going to be an equal game that we can all enjoy playing. So look at that. It's going to take me a lot more clicks to get that LED to move an entire block. So that's how we can create this tug of war game and make it better. There might be, though, some bugs in this game. We need to make sure that we use the round number to make sure the LED knows where it needs to go. And let's say that we've changed our values that we're changing our rope by 0.3 and 0.3 there. Sometimes when we get to here, it won't potentially equal -1 or +5. So what we need to do is maybe have a way where we can say, well, if it's ever less than or equal to or greater than or equal to that there. That will fix all of your bugs. And that is the end of our game. Go off and play and let's see who wins.